Let's go through Liquid 1,230 toss string coins. For this question, it gives us um, a double array props. Means there are for those kind of coins. For each coins, it has a possibility of this number, this double number that it will face up. So it asks what's the possibility that the target number of coins being facing up. So let's look at uh, how can uh, we can think about possibly this question actually is some kind of dynamical programming. We can use uh, DP, for example, IJ means for the previous ice coin, if we already have J's uh, number, const J number face up, what's the possibility, right? So we will say this comes from two parts. One is that if we add one coin, right? So that is I minus one coin. We already have J face up, right? In this case, we should add to our result, right? So what is this possibility? This possibility is for this coin should be we should not face up. So should one minus possibility I, right? Another is that for the previous I minus one, we have J minus one face up, right? And we need the current one to be face up. So we should have possibly I multiply this one, right? Then in the end, we just return for the n coins if we have a DP n target, right? The, that will be our result. So let's write code for this. We're going to have int n equals product length, right? So we're going to have a double dp equals new. We can have one more have n plus one, right? Also target plus one, right? Because in the end, we want to return n target, right? So dp I j means the previous I coin, right? And the j up possibility, right? Probability. So we can have the things that we need to have put to this one as 1.0, right? Otherwise, when we sum up, it will always be zero. That means if we don't select any coin and we have zero coin up, this is always the truth. So it will have 1.0, right? So what it is that for int I equals 1, I smaller than n plus 1, I plus plus, right? So for int j equals 0, j is smaller than target plus 1, j, this one, right? So we're going to have dpi j, which should have two parts, right? Um, so we are the things that because this j it can be 0, right? So we are right. So first the thing is that it's coming from probability I minus 1, right? So that means multiplied by dp. That means current one we don't face up dp I minus 1, but for the previous I minus 1 coins we already have j coins up, right? And also, we because we want to have j minus 1, right? We'll write if j is greater than 0, then we'll have dp I J should plus equal to current one with face up, right? And for the previous one, that is we have J minus one face up, right? So in the end, we just return dp and target. It will be O n multiplied by target time complexity and also O n multiplied by target space complexity. Python code will be very similar. N equals the length of prob, and we're going to have dp equals 0 and 0 multiply uh, let me see. Actually, you'll see we have one thing, right? So let's see. Actually, we can have space. Um, we don't need the first dimension of the space. You'll see, right? Because you'll see, uh, we can get rid of this, right? So we can set as this because every it is coming from I minus one J, right? And I minus one J minus one, right? Um, I minus one J minus one. Mm. So we can actually write um, for J. You see, so we should have J. We can write this for int J equals target J greater equal to greater than 0 J minus minus, right? So we'll have dp I dp J should uh equals 1 minus prop I minus 1 multiplied dp J plus prop I minus 1 J minus 1, right? But the thing is that this one will also need to change. And can write we can write this J greater than 0, right? And otherwise this is 0. So we can put this one into one dimension, right? Right. I minus 1. Sorry. So let's look. So this one, let's see. We can get rid of one dimension for this question, right? So we can also write a Python code for this. Mm, so Python code, let's write. So this one will be target plus 1, right? Then we're going to have dp0 equals 1.0. So for I in range n, we can have um, for j in range target to 0 minus 1, right? Minus 1, because we can set this one as 0, right? So we'll see into p the p probability equals um uh probability I multiplied by dp j minus 1 if j is greater than 0, uh, else 0, right? So we're going to have um, dp j equals 1 minus prop I multiplied by dp j plus p, right? And in the end, just return dp target.